In this video, I will discuss about algorithm, pseudocode and program. Let us learn about them. First of all, algorithm. What is this? By definition, algorithm is a step-by-step procedure for solving a computational problem. Then what is a program? Program is also same. Step-by-step machine instruction or program instruction for solving any problem, that is computational task. Then what is the difference between algorithm and program? See, we have started writing programming recently, but algorithms are existing from centuries. People have been devising procedures for solving computational problem. This is a common practice. Who were doing this? Mostly mathematicians were doing it or scientists were doing it. So those who were working on some problem, studying a problem and finding a solution, they were giving a solution in the form of algorithm, that is procedure, step-by-step procedure. Now we want that same procedure should be followed by our machines, so we are writing program. Okay, yes, that's it. So it means first we have algorithm, right? First we have algorithm, then we convert that into program. Yes, exactly. Then as a student, if you study, what do you learn here? You learn how to solve a problem. This is different. How to solve a problem, right? So are you capable of solving any problem? It's not easy to start solving problems. First of all, you learn few procedures, then from that you get some new idea, then you can start solving the problem by yourself. You need some skills, you have to develop some skills, analytical skills or problem solving skills, you have to get it. So that mostly you get from various other subjects as well as mathematics, not purely completely mathematics, various other subjects, and it depends on your IQ level also, how to solve a problem. So if you know how to solve a problem, you can write it as an algorithm. It is just like if you know how to prepare a dish, if you are a chef, then you will prepare a recipe, right? If you are a chemist, then you will prepare a chemical formula and you will prepare an experiment for chemical formula, getting the chemical result, right? If you are a musician, you will compose music. So if you are a mathematician, you will write an algorithm, that is procedure. That's it. So this requires different skills, right? So mainly awareness of your mathematics and awareness of problem solving. And if you have algorithm, then we want our machine to perform that algorithm and get the result, write it in the form of a program. So converting an algorithm into a program. So that's what you should know, the language. So if you know the programming language, then you can pick up that programming language and write on a program. Convert this into this one. Then how do you write, in which language you write this one? We can use any language here, English like language, or directly English also you can use here. But people use some formal notation. It looks more like mathematical or more like programming like. So that type of code we call it as pseudocode, right? So pseudocode is not defined, not a standard. Whatever you write is pseudocode, right? Sometime we define, a team will define and follow that one. Otherwise, if it is understandable, that's enough. You write any way you like. But program, you must strictly follow. If you're using C++, then you should strictly follow syntax, means grammar of that particular language. Here, there is no grammar. As long as one can understand, if a person can read, at least if you are writing, you should understand it. That's enough. That's a pseudocode. So analysts or mathematicians who know how to solve a problem will write algorithm and programmer will write on a program. So now as a student, as a computer science student or person, you have to devise an algorithm and you have to write a program. But so many algorithms are already available, we struggle learning about them only, that is sufficient. If you know about all existing algorithms and you know how to convert them into program, that is sufficient. You don't have to invent anything new. Unless and until you need it and if it is not existing, right? So this is the general idea about the algorithm versus program and also a pseudocode I gave you. For learning programming, people will first write algorithm, then they will convert into a program. So that if you have a practice of this one, then later on, if at all you have to devise your own algorithm, you should be able to do it. You should not be new to algorithms. Now let me write an example algorithm, and also for that I will write on a C++ program, though I am not going to explain you how that program is written and all, just a sample to look at. Let me write down. So here I have an example algorithm as well as a program, that is C++ program. That is not a complete program, just a function. Let us study this. See, this is for finding average of list of elements. I have collection of elements, I want to find out average. Read it. Sum is 0, okay. Sum assign 0. This means put this 0 inside sum. Yes, that's the meaning. The arrow is showing me the direction. Then for each element x in list, so we will call each element as x in the list. Then begin. Sum assign sum plus x. So go on adding the element in sum. So this portion is adding all the elements. Then after that, average assign sum by number of elements, though I get an average, then return average. So if you read, you can understand. For finding the average of list of elements, add all of them and divide by number of elements. That's it. How it is written? Is it English? Not exactly English. Similar to English. Is it a C++ program? If you have ever seen it, is it looking like that? No. But is it readable? Yes. Then what is this code? Pseudocode. It's a pseudocode. So let us make some changes. Instead of writing this, can I say colon assign equal to colon equal to? This is also showing a direction. Then here also colon equal to. Yes, you can write. You can write. You can write right. So if you want change the symbol, change the symbol. Alright. For each element x in list, do. Mostly we find like this. Do this. Okay, you add it. That's also meaningful. So instead of begin and end, I will say flower bracket. Yes, that is also showing the beginning and ending. No, I will use a square bracket. Okay, use it. So now this is sufficient. The idea is whatever you write, it should be readable. Right? It should not, one should not get confused. At least for whom you are writing, they should not get confused. This is how we write a algorithm using pseudocode. Now the same thing for finding average of list of element is a C++ program. Is a C++ program. It's a function. It's not a complete program. Just a function. Inside this, if I don't give semicolon, it's an error. And instead of assignment, if I write less than and hyphen, it's wrong. Compiler say, what is this? If you want to store the value here like this, if you want to store the value, you must use equal to symbol, and that is called as assignment. You must write like this. So wherever you like, if you write semicolon, it will not work. So it means you should follow the proper syntax of a language, because this is not for you. This is not for you. You are writing it for the compiler to understand it and convert it into machine code. So you will write C++ program, and that gets converted into machine code or machine language. Who converts that? Compiler will convert this. So you are talking to compiler actually. So you should talk such a way it easily understand. If it is not understanding, it cannot convert it into machine code. So this language is a language of compiler. So you should follow the syntax perfectly. That is the reason you have to put some little extra efforts for learning programming. Initially you'll do mistakes, you will not write the things properly, you miss few things. You'll not know what errors you get. Once you start getting errors, you will start realizing, okay, these are the mistakes I am doing. So from mistakes you will learn programming. So that's all about the comparison of algorithm, pseudocode and program. So I have given you enough basics. So that's all in this video. So the next topic is flowchart.